Welcome all of you. Welcome back again. So in our previous class we were discussing about limit test. In today's class as also we will continue with our limit tests. In today's class we will discuss about limit test for iron and heavy metals. We will discuss about limit test for iron and heavy metals. Now all of you, before starting the class, before initiating about the limit test for iron, I would like to give a brief explanation about what is a limit test. What is a limit test? So, a limit test is defined as a quantitative or a semi-quantitative test. Limit test is a quantitative or a semi-quantitative test. It is used to identify, control small amounts of impurity. It is used to identify and control small quantities of impurities which is likely or which might be present in our sample substance. Okay. So what does a limit test do? It cannot exactly quantify. Limit test जो है ये exactly quantify नहीं कर पाएगा. It cannot exactly quantify the amount of impurity which is present. That is why it is known as a semi-quantitative method. That is why it is called as a semi-quantitative method. यहाँ पे क्या होता है? We take two cylinders. Now limit test is performed using a Nestler cylinder. Most of the limit tests for chemical compounds are performed using Nestler cylinder. Okay? Nestler cylinders are made up of glass. They are made up of glass, high quality, high grade borosilicate glasses, which gives very good see-through property, which has got a see-through property. So what do we do in a limit test is, we take a test Nestler cylinder, we take a test cylinder and we have a standard cylinder. First we take a test sample and next we take a standard sample. Test mein what do we use? What are the contents which we put inside a test cylinder is our sample. Okay. Test comprises of our sample which we want to check for impurity. Next, standard contains, this is unknown, okay, this is unknown, whereas our standard contains known. It contains known quantity of our standard. Alright, if we would like to check for the impurities for sulfates, okay, suppose I am going for the limit test of sulfates, then my sample is unknown. Standard, I take a known quantity of sulfate as standard. I take a known quantity of sulfate as standard in my standard test tube. Okay. Then we add the reagents and next we look out for reactions. If we talk about iron here, then in my test I add my sample which I need to check for iron. Then in my standard I add known amount of iron as standard. Known amount of iron as standard. Okay. Then I check for either opalescence or turbidity or change in color. Alright. So what is a limit test? It is defined as a quantitative or semi-quantitative test designed to identify and control small quantities of impurity. It is designed to identify and control small quantities of impurity. By small quantity I mean, जैसे कि हमारा जो standard value है, it is already mentioned in our pharmacopoeias. We have a set standard value for specific impurity. Okay. So if my sample contains impurity lesser than that standard value, we can know that our sample passes for the limit test. Okay. If it contains more than the standard value, then we will come to know that our sample contains the impurity higher than the standard. Okay. But what we don't know here is, what is that quantity which is going over that of the standard permissible limit. What we don't know here is, what is that quantity, how much of quantity is moving over that of the standard. Alright. So this is where our limit test gets its constraints. So now moving on further towards understanding the limit test. So what is a limit test? It is a quantitative or a semi-quantitative test designed to identify and control small quantities of impurities which is likely to be present in the substance, which is likely or it might be present in the substance. What is the importance of limit test? Well, limit test is used to find out harmful amount of impurities. As I said, it is used to find out that quantity of impurity which is over that of the standard permissible limit. So, it is used to find out harmful amount of impurities, followed by it is used to find out the avoidable or unavoidable amount of impurities. It is used to find out avoidable or unavoidable amount of impurities. Next, limit test involves simple comparisons. What does a limit test do? It involves simple comparisons of opalescence. It involves simple comparison of opalescence, turbidity or color. Opalescence, turbidity or color produced in a test with that of the fixed standard. Produced in the test with that of the fixed standard. Alright. So, as we've discussed in our previous class, we will just brush up again what are the different types of limit tests. Limit test for chlorides, limit test for sulfates, limit test for iron, arsenic, lead and heavy metals. Followed by the last modified limit test for chlorides and sulfates. Modified limit test for chlorides and sulfates. So, one by one we will be looking into each and every limit tests. Okay. I hope I have made this concept about limit test clear. Okay. Because if you understand what a limit test is, in our previous lecture slides, we will look into how a limit test can be performed. Okay. What are the components of a limit test? What is the output which we are expecting in a limit test? That we will see in our upcoming slides. Now, as I mentioned, in our previous classes, we had discussed about limit test for sulfates and limit test for chlorides. Now, we will look into the limit test for iron. Now, we will have a glance onto the limit test for iron. Okay. So, what do you mean by limit test? Again, the limit test for iron, first we will understand the principle. Okay. Now, for writing down every limit test or for understanding a limit test, there are 4 components. There are 4 components. Number 1, principle. Okay. First, we need to understand what is the principle lying behind the limit test for that specific substance. Principle followed by reaction. Followed by reaction. The chemical reaction which is happening inside the system. Alright. Followed by the procedure. The procedure. Followed by the procedure. Followed by the reagents used. The reagents used for performing the limit test. Okay. A very important 2 points which you need to understand, which you need to remember, which you need to memorize is what is the standard quantity of our standard, what is the permissible quantity of the standard, and what is the color of how are you identifying the difference between test and standard. Okay. I should not say color, I should rather say what is the basis of identification of the test and the standard. How do we compare the test with that of the standard? It could either be opalescence, it could either be turbidity, it could either be a change in color. It could either be a change in color or color intensity. Okay, it could either be a difference in the color or difference in the intensity of the color. So, with this we move on further to understand limit test for iron. Now, the limit test for iron is based upon the formation of pale pink to deep reddish purple color. Okay. So, what happens here is, how do we compare the test with that of the standard here is, we compare the change in color. We compare the change in color. Alright. So, when we add a reagent, if my cylinder or if my sample contains iron, it will give either a pale pink to deep reddish purple color. Deep reddish purple color. Alright. So, this will be our mode of identification. Now, moving on further on to limit test for iron. Limit test for iron involves reaction of iron with thioglycolic acid. Here, iron is made to react with thioglycolic acid in the presence of citric acid. Okay. The solution is made alkaline. With ammonia solution. Alright. So, limit test for iron, how do we perform? We make iron ferrous. We make our iron to react, or it involves the reaction between iron with thioglycolic acid. Thioglycolic acid is our reagent. It is our reagent. Okay. Now, here what do we do is, the iron is made to react with thioglycolic acid in the presence of citric acid. And alkaline medium. This reaction has to take place in alkaline medium, for which we add ammonia solution. Okay. So, what happens in this reaction is, in this reaction, ferric ion is first reduced into ferrous ion. Fe3 plus ion is reduced to ferrous state, Fe2 plus. Okay. Ferric ion is reduced to ferrous ion in the presence of thioglycolic acid. This reaction further proceeds, that is, the ferrous ion further reacts with thioglycolic acid to form a coordination compound. Known as ferrous thioglycolate. Okay. The color produced is compared with the standard. The color produced due to this reaction is compared with that of the standard by viewing transversely through the Nessler cylinder. Okay. So, what happens here is, suppose our ferrous ion is made to react with thioglycolic acid. So, how do we remember the structure of thioglycolic acid? We write carboxylic acid, that is CH3COOH. If one hydrogen of the carboxylic acid, this is our carboxylic acid, right? If one of the hydrogen is substituted by a thia group, instead of CH3COOH, it becomes CH2COOH, and carbon is attached to a thia group. It is known as thioglycolic acid. Instead of this thia group, if we attach hydroxyl group, it becomes glycolic acid. Okay. So, now this thioglycolic acid converts, first of all, in the step 1, it reduces the iron. Okay. This is step 1. What happens in step 1 is, iron in its Fe3 plus state reacts with thioglycolic acid and gets converted into its reduced state Fe2 plus. Fe2 plus. Okay. Reduction reaction is happening here. Reduction reaction is happening here. This Fe2 plus further reacts with another molecule of thioglycolic acid to form a ferrous thioglycolate. It is a coordination compound. It is a coordination compound. Iron forms complex with thioglycolic acid, two molecules of thioglycolic acid to form ferrous thioglycolate. It is a chelate. It is a chelate. Okay. This chelate produces the pink or the reddish purple color. Clear all of you? Very simple. If there is no iron in my sample, it will not form a complex with thioglycolic acid. It will not produce the color. Okay. If my sample has iron, it will form a chelate with the thioglycolic acid and gets converted into a ferrous thioglycolate complex which has reddish purple color. Clear? Very simple principle. Reaction is as simple as that. Only thing is we need to remember what are the reagents being used and what is the reaction which is produced and what is the color change. Okay. Now, if the purple color produced in the sample is less intense than that of the standard, see, iron, if it is present in the sample, it will give purple color. If the quantity of iron is more than that of the standard, the intensity of purple color will also be high. Clear? Intensity of purple will also go up in the similar ratio. So, if the purple color produced is in the sample is less than that of the standard, it means that our sample will pass the limit test for iron and vice versa. Clear all of you? Now we will see a diagrammatic representation for the limit test of iron. Again, reaction as we have already discussed. We take two Nestle cylinder, one test and one sample. This is our test Nestle cylinder and this is our standard Nestle cylinder. Test and here we have our standard Nestle cylinder. Okay. One we take sample solution, another we take 2 ml of standard iron solution followed by distilled water up to 40 ml. Next we add 2 ml of 20% citric acid. Next we add 1 ml of thioglycolic acid. We add 1 ml of thioglycolic acid. Next we observe for the change in color. After making the solution alkaline, how do we make the solution alkaline? By adding ammonia solution. We check with litmus paper. We will check with our pH paper. The solution has to be alkaline. Then we check for the color produced. If you see here, the intensity of purple, reddish purple produced in our test is less than that of the purple color which is produced in our standard. Okay, which is produced in our standard. So, our test passes the limit test for iron. So, what are the reagents used? What are the reagents used in the limit test for iron? We use standard iron solution. We use standard iron solution which is 0.1726 gram of ferric ammonium sulfate. We use 0.1726 grams of ferric ammonium sulfate and dissolve it in 10 ml of 0.1 normal sulfuric acid and make the volume sufficient with water sufficient to 1000 ml or 1 liter. The next reagent which is used is iron free citric acid. It forms a soluble complex with iron and prevents its precipitation by ammonia to ferrous hydroxide. That is why we use citric acid. Next we have thioglycolic acid. Next we have thioglycolic acid which is a reagent which forms the coordination complex. It is a reagent forming coordination complex. So what does this do? It reduces ferric ion to ferrous state. It reduces ferric ion to ferrous state and forms the complex. followed by ammonia solution. Ammonia solution is used to make the solution alkaline. It is used to make the solution alkaline for the development of the color. Alright, so I hope limit test for iron is clear for all of you. Now we move on further towards limit test for heavy metals. Limit test for heavy metals. Now students, in our today's class, we will have a brief overview about the limit test for heavy metals, okay? And in our next class, we will look in depth into limit test for heavy metals. In today's class, we will try and understand what are heavy metals, what are the types of limit tests for heavy metals. In our upcoming classes or in our next class, we will look into how do we perform the limit test for heavy metals, and we will look into each and every types of limit test for heavy metals in detail. Now, the limit test for heavy metals is designed to determine the content of metallic impurities that are colored by hydrogen sulfide or sodium sulfide under the condition of the test. The heavy metals are mostly metallic impurities. They may be iron, copper, lead, nickel, cobalt, bismuth or antimony. The limit test for heavy metals is indicated in the individual monograph in terms of ppm of lead. Okay, so it is compared in terms of ppm for lead. The parts per million of the substance being examined. The usual limit as per Indian Pharmacopoeia for heavy metals is 20 ppm. The Indian Pharmacopoeia has adopted 4 methods. Okay, our Indian Pharmacopoeia has adopted 4 methods named as A, B, C and D for the limit test of heavy metals. Okay, for testing for heavy metals, our Indian Pharmacopoeia has mentioned 4 tests which are noted as A, B, C and D. The principle involved in the limit test, if I talk about method 1, 2 and 3 is, they are based upon the reaction of the heavy metal ions with hydrogen sulfide. In method 1 and 2, hydrogen sulfide is used as reacting reagent or sodium sulfide. Alright, that is in method 3. The metal sulfide remains distributed in a colloidal state and gives rise to a brownish coloration. The color produced in the test solution is compared with that of the standard, containing a definite amount of the lead. What happens in method 4? Well, the method 4 is based upon the precipitation of relatively insoluble and characteristically colored sulfides. Okay, so these are used for colored sulfides of heavy metals when aqueous solutions are treated with alkali metal sulfides. Here we use alkali metal sulfides as our reacting reagent, whereas in our previous test we used hydrogen sulfide as our reacting reagent. Here we use alkali metal sulfides as our reacting reagent. The color or turbidity or what do we need to check here is heavy metal sulfides are brown colored. Okay, so if our heavy metal forms a sulfide, then it gives a brown coloration. This brown coloration formed is compared, that is the brown coloration formed in the test is compared with that of the standard. Okay, standard as I've already mentioned, we take a known quantity of standard, whereas in our test we have our unknown quantity. So this being a semi-quantitative test, we can simply say whether our sample passes for the limit test or it fails. If the brown coloration formed, if the color intensity formed is more than that of the standard, that means our sample fails for the limit test of heavy metals. Whereas if the brown coloration formed is less than that of the standard, then it passes the limit test for heavy metals. Alright. So in our today's class, we have discussed about limit test for iron in detail, and we just had a brief overview about limit test for heavy metals. Okay. So in our upcoming class, we will discuss in detail about the limit test for heavy metals. Why is it required? What are the different types of limit tests for heavy metals? How is one different from the other? Thank you.